Hi everyone, welcome back to our channel. Let us try to see the derivation for interconnection of two-port network of parallel interconnection, that is nothing but the sum of y parameters. So in the previous lectures we have been completed z parameters, ABCD parameter. Now we are going to solve the y parameters. So here, before considering in parallel interconnection, let us try to see how the circuit diagram we are going to parallel interconnection. You see this parallel interconnection here. Generally this parallel interconnection is made for, so here parallel means current division will occur. In current division occurs means they are connected in parallel. Which parameters are in terms of I parameter are nothing but y parameters. So that's why it is suitable to prefer y parameters to understand this parallel interconnection. So I'm going to take a network with the name I mean two-port network. So it has two terminals like this, and I'm going to select a network, two-port network B, and now I'm applying a voltage of V1. Here I am applying a voltage of V2. The current into the network is I1, and this current into this network is I1 here. And now I am also having two terminals here. I am having two terminals. So I am going to join these two terminals, and now I am going to join positive to positive and negative to negative. I can say they are connected in parallel. So here the total entering current is I2. The current into this two-port network is I2A, and the current in this branch is I2B. The current in this branch is I1B. Therefore here current division means, so the voltage at this point is also V1A. The voltage at this point is also V1B. The voltage at this point is V2A. The voltage at this point is V2B. So I can say that these two are connected in parallel. V1 is equal to V1A. The voltage at these points is V1. The same voltage V1A is also the same voltage V1B. So V1A is equal to V1B is one equation, and again here V2 is equal to V2A, that is equal to V2B. And now we want in parallel. So you can see here A and B are now two-port networks are connected in parallel. The current entering at this port, how I am going to write down is, the total current I am going to write down it as I1 is equal to I1A plus I1B, and to this network apply the Kirchhoff's current law at output port. So the entering current is how much? I2. So I can write down I2 is equal to I2A plus I2B. So where I2 is the entering current, the leaving currents are I2A and I2B. So now we want to sum like this. Before summing, let's try to write down the basic y parameters. I can write down I1, I2 is equal to y11, y12, y21 as well as y22. So this is nothing but the y parameters multiplied with v1 as well as v2. And similarly here I1, I2 is equal to y11, y12, y21, y22 multiplied with v1, v2. So this is with respect to A I am taking, so put the suffix A here. And this is with respect to two port network B, so put the suffix B here. So now you want to write down this expression. So okay, you can write down I1 is equal to, how to write down I1A. How to write down I1A? I1A is nothing but Y11A V1A plus Y12A into V2A plus I1B. What is I1B? This is I1B. Row multiplied with the column. So we can write down this as Y11B V1B plus Y12B V2B. So this is one equation, and second one is use this here. So I can write down I2 is equal to I2A. How to write down I2A? I2A I can write down it as Y row into column Y21A V1A plus Y22A V2A plus, how to write down I2B? I2B you can write down row multiplied with the column. So here I can write down as Y21B V1B plus Y so here we can write down as Y21B Y22B into V2B. So already we are very clear that this is from here we have written V2 equal to V2A equal to V2B. So and we are very clear that V1A so V1A V1B equal to V1. So substitute this V1A and V2A. Okay, so therefore compare this V1A V1B can written as V1. Take V1 as a common, we can write down Y21A plus Y21B. Take V2 as a common term here because V2A equal to V2B equal to V2. So when you take V2 as common, then we are going to get Y22A plus Y22B. Similarly, here V1A and here also V1B, V1A, V1B equal to V1. So I can write down I1 is equal to V1 into Y11A plus Y11B plus V2A is equal to V2B equal to V2. So take V2 as a common term here. So V2 is equal to Y12A plus Y12B. So when you compare these two and write down in matrix form. So when you write down in matrix form both equations, I1, I2 is equal to, so you can write down it as Y11A plus Y11B. Next one Y12A plus Y12B. And I2, so this is I1 in terms of V1 and V2. So I2 is equal to Y21A plus Y21B, and here Y22A and Y22B. So you can see here when you perform the parallel connection, so we have been performed the parallel connection of A and B. I already told current division will occur. Current division occur means we want an parameters which are in terms of I. In terms of I is equal to Vy. Which parameters are there? Y parameters are there. That's why we expressed, just we take it parallel and we written the KCLs and KVL at input and output port. We got this I1 is equal to I1A plus I1B, I2 is equal to I2A plus I2B, and written in standard format. So in parallel connection of we have to see that this is nothing but sum of y parameters. So in parallel interconnection of two port, we have to perform the sum of y parameters, which plays an important role in our analysis. This is all about parallel interconnection of y parameters. Hope if you want to review the previous video, you can check. The series connection is a sum of z parameter. Cascade connection is a product of ABCD parameter. Parallel is a sum of y parameter. If you are watching the channel for the first time, please like the content and share with your friends. And if you have any doubts, let me know in the comment section. And if you are watching the channel for the first time, subscribe to the channel with the name KV Tulsi Ram. We'll meet in the next video. Yours obediently, Ram.